Good morning, good afternoon, and good evening. Welcome to our webinar, Optimizing Your Cloud Applications in RightScale. This is the second webinar of our four-part October series called I'm in the Cloud, Now What? Today's webinar focuses on our experiences scaling and performance tuning the RightScale platform in the cloud, and we're going to share some tips with you on sizing, auto-scaling, and monitoring. However, before we get started, I have a couple questions that I would like to ask you. So we're going to go ahead and load up a few polls. The first question is, are you using the cloud today? We define the cloud as infrastructure as a service, so using tools like Amazon EC2 or Rackspace, or maybe you're on a private cloud. So take a moment to answer this question. The first option, yes, very much with one or more serious projects. That means you're running at least maybe a handful of production applications in the cloud. Maybe you just have one project. Maybe you're just beginning to explore, or just no, simply you're not using the cloud today. So we'll leave this open for a few more seconds, and we'll share the results with you guys. Thanks again for your patience. Okay, we're going to go ahead and push out the results. Okay, cool. So it looks like a very large percentage of the audience actually has production apps in the cloud, so that's really good to know. And there's a portion of you guys as well that are just getting started or maybe just have one project. And not surprised to see that no one is not running in the cloud. That was awkwardly phrased. Okay, let's move on to the next poll. Quick and easy question here. Excuse me, what is your role? So just select one. Developer, sysadmin, ops, architect, or business manager. And so this one's pretty obvious. We're trying to understand what percentage of the audience is in more of a technical role versus in more of a business role. So we'll leave this one open for a few more seconds. Cool. Push the results out. And again, not surprised to see that 90% of you are in a technical role with a heavy sway toward the sysadmins and ops people and the architects. Cool. Thanks again for your responses. Final question, and we will move on. Last question. Out of curiosity, what kind of database or databases do you use or do you plan to use in production? So this one, select all that apply if you're running multiple. So MySQL, SQL Server, Postgres, Oracle, or a NoSQL database. If you're running a different kind of database, our apologies for not including that. GoToWebinar only allows us 5. Leave this open for a couple more seconds. And let's push out the results. Interesting. Okay, so the majority of you have a MySQL server, and then half of you have NoSQL. So good to know. Thanks again for your responses here. And let's get started with the webinar. I'd like to introduce our panel for today. We are joined by Rafael H. Saavedra. He is our Vice President of Engineering at RightScale. We also have Rafael Simon. He is a Senior Systems Architect at RightScale. So you might be wondering how you can keep a webinar with two speakers named Rafael straight and know who's talking. So I'd just like to let you know that Rafael, the VP, has a Spanish accent, and Rafael, the architect, has a French accent. So you should be able to tell the two of them apart as they are taking their turns on the webinar. One thing I'd like to point out, a really great thing about GoToWebinar is the questions section. So take a look at the main GoToWebinar control panel. Jordan Evans, our account manager, is standing by to answer your questions as they come in. Also, throughout the course of the webinar, Rafael will pick some of the questions that are more generally applicable to the audience as a whole, and we'll answer those live on the air. So make sure to make sure to ask questions early and often, and Rafael's and Jordan will make sure to get answers out to you quickly. So with that, Rafael, I will hand it off to you.
Thanks very much, Sarah. So welcome, and well, I'm Rafael, the one with the Spanish accent. So why don't we start? Let me just go quickly through the agenda. I think we're going to start with some simple introduction. Given that most of you have already plenty of experience in the running application in the cloud, probably going to go pretty fast because most of these things are pretty obvious to you. And then we're going to talk a little bit about the architecture. We're going to focus most of our examples, and this is a three-tier application architecture. Then Rafael PH is going to talk about how to do, what it means to do vertical and horizontal scaling. And after that, we're going to show you more all the tools that we provide in RightScale so that you can monitor the performance of your applications, detect anomalies, maybe get alerts, escalations. And some of you may not be aware of the new feature that we have. There is cluster graphs that are very useful, and we ourselves use it a lot in production. And then we're going to change and show you a tool that we also use in our systems, that is a partner tool, that is New Relic, the RPM. We have found that it's a very good tool to use if you want to really understand what is your application doing and if you want to optimize it. And finally, we're going to talk a little bit about how to support optimizing the DBD performance. So most of you said 70% are using MySQL as your database. So we're just going to share with you some tips that we normally use. As probably you're aware, optimizing a DB performance is an ongoing process that has to be done every day. And finally, we're going to talk a little bit about load testing. So let me start. So, okay, when we say cloud computing, what are the main characteristics that we the ones that use it, love it, and basically find very attractive relative to other alternatives? Well, the first one is, well, it's multi-tenancy. That is that you share the resources of the machine can be with other users. This is made available by the use of a hypervisor. Then another very important thing is that the cloud is a shared resource pooling, and that's wonderful because that means that everybody benefits from this huge shared resource, and because the availability is there for everyone, but the needs change over time, then people who have high requirements at a certain point in time can have access to many resources, and then people who don't need them just basically don't have to pay for them. The other advantage is that is geo-distribution and ubiquitous network access. What that means is that the clouds, as they mature, you can basically find resources around the world. An example of that is Amazon, that has now 5 regions, and I'm pretty sure they have plans to continue expanding, and similar for other cloud providers like Rackspace and also the new ones that are coming. The other interesting thing that I think makes it all of us to love it is that it's service-oriented. And what that means is that it uses an API so that programmatically you can ask for resources, you can provision them, you can start it, terminate them, and therefore it's very convenient because it makes possible to write complex applications and complex workflows systems that can adjust and respond to the needs. And that's basically tied to dynamic resource provisioning. That is, you can ask for resources the moment that you need them. It's another characteristic is that it's self-organizing in the sense that your application grows and has a need for more resources. Well, you can basically allocate them, and what you have is a reflection of what your application needs more than a pre-architecture designed that may not reflect the actual use. And the final, but not maybe the most important, is that it's utility-based pricing. That what means is you only pay for what you consume. So I think we already mentioned most of the advantages, but just to repeat them is no upfront investment. Then you also lower your operating costs because you have you have to maintain and support the servers that and the resources that you need. It's highly scalable. As there are as many resources as you are willing to pay or your business is willing to support. It's very easy access, again, by using an API. And most important, for new businesses or for new enterprises, it reduces the business risks and maintenance costs because you don't have to do a planning ahead of time, trying to predict what is going to be the response from your users. You can just experiment. You can have several projects going at the same time, and then you can add more resources to those projects that are successful and limit them for those that are not. And the other thing is it enables process automation. That is something that I think is going to become more and more important in the future. So let me just introduce what we talk about, the three-tier application architecture. It's something that most of you are very familiar. And the idea is that what you have is a hierarchy of resources, organized that at the front you have your load balancers. Is that when your customers send requests to basically your to the URLs that define your site, your DNS providers route these to your balancers, and the load balancers who are basically monitoring your app servers. And let me just show it here with the red. Your load balancers basically are monitoring all your app servers, and you can have as many as your customer demands require. They know the health of them, so they can route requests so that they can keep the load on them as uniform as possible. And also they know if one of the servers goes down to make sure that they don't send requests. And then all these application servers are mostly stateless, so that it's easy to add or to reduce the number of them as the demand increases or decreases. But all of them are connected to your database. That is where you keep your state and all the information. And this master database, if you're using more of a standard MySQL kind of architecture, may be doing some replications to the slave, and both of them, the master and the slave, may be doing some snapshotting and sending that to storage. So I think everybody should be familiar with this. So now let me change and give the mic to Rafael, and he's going to tell you a little bit about vertical and horizontal scaling.
All right, so let's switch to the French accent. And so I'm going to talk a little bit at the high level about the different ways that you can go to optimize your applications running on the cloud. And there are basically three ways you can do that. One is, the first one is called vertical scaling. And it's basically a pompous way of saying, I'm going to run my application on bigger box. The second way is horizontal scaling, and the idea here is that bigger box only gets you so far. At some point, you're going to run out of bigger boxes, and so you need to scale by adding more boxes. Now, the drawback there is that this has impact on your application architecture. You need to make sure that your application is stateless, and that you can just add new boxes to increase performance. The third way is actually improving the performance of your application. And so what we do there to help you with that is all of our server templates come pre-configured with scripts that will install collectd and will capture in real time performance data and report that in our dashboard. So we will report data about the hardware, but also about OS, and we also have some specialized plugins for some of the applications that are available through our server templates, so things like MySQL plugins, HAProxy, etc. And we will present information to you in various ways so that you can then analyze it and make decisions on how to optimize your applications. And we will go into those different graphs later on. And finally, you can also use that data to create alerts and escalations, meaning that you can automate the behavior of your application based on this monitoring data. And that's the basis for server arrays, which we'll cover next slide. We also integrate with third-party products which specialize in performance analysis and improvements, and one of them is Nordic RPM, which we'll go into more detail later. So if we take a look at, as an example, at the spectrum of instance sizes available on AWS, so that would be to cover the vertical scaling use case. You can see that there are basically three major groups of sizes. One, the smaller group on the bottom left here is test and dev, and what that is basically smaller size boxes which you can use to develop and test your application. And on the right here, we have the high-performance computing boxes, which are mainly meant for things like grid computing, things where you need to process a lot of video and audio, for example. But the vast majority of the sizes consists of the more traditional app server kinds of instances, and you can start, with the small. If you're just starting a new business and the load is very weak, then you can just start with a small instance. But then, as the load increases, as the requirements for performance increases, you can then go up that chain into bigger boxes, and at each point you can consider whether you need more memory or whether you need more compute, what Amazon calls compute units, which is basically CPU power. And once you are at the M2 quadruple extra large size, that's when you really need to look into the other two ways of scaling. So horizontal scaling usually applies to the parts of your app that is stateless. So what Rafael was saying before is the application servers in a classical three-tier architecture would be a perfect candidate for running, for being scaled horizontally. And the way we do that in RightScale is we do this through those server arrays. And the way this works is we will allow you to create tags on servers, on instances that are running a part of the array. And those tags can be created as a result of any kinds of metrics reaching any kind of threshold and for a certain period of time. So you can decide how long that threshold has to be reached before that those tags get created. And you can also decide how long, what the period of scanning is between each iteration. And once you have set up all those tag creation, those alert escalations, our system will provision or will terminate instances in the array dynamically. And we have a set of instructions, detailed instructions available on our support website, which I'm going to show you right away. So here on this page, we have a set of instructions that shows you how to set up this auto scaling. And I encourage you to look at it if there's something that you are interested in. So I'm just leaving it here for a few more seconds so you can take a note of the title here, set up auto scaling using voting tags. Okay, so what this system allows you is really define conditions that are specifically tailored to your application. So you can decide how quickly you want the array to scale. You can also decide where the array should scale, and you can decide whether it should be scaling, whether you want all your workload to run in one region, or whether you want to have multiple regions or availability zones where you want to run instances, so that if one availability zone has connectivity issues, your application can still perform. Also, what the server array allows you to do is have a consistent set of configuration settings. So you don't have to configure each server individually. You do the configuration at the deployment level, and then it will apply to every instance launched in that server. And also, one of the settings that you can tweak on the server array is how many instances do you want to always be running at the minimum, and you can also specify a maximum. So it's a fairly there are a lot of knobs that you can turn to really have the right settings for your application. Okay.
So I think we're going to move to the next section, but there are a couple of questions that we may want to, we're going to try to answer for you. The first one is, are the load balancers software-based or hardware-based, e.g. F5, switch, etc.? I think the answer is, the way we are explaining it in this talk is it doesn't matter. They can be either one, but it's the same idea. Is a set of resources that are taking requests, and then by monitoring the application server, the status of the application server, they're making decisions how to route these requests so that they can be processed as fast as possible, and that the load tend to be more or less constant. We ourselves tend to use a software-based load balancer. However, these results of these lessons applied equally well if you're using Elastic Load Balancer with Amazon or something else. The second question, I'm going to leave that one for Rafael, is just IP1 and IP2 in the diagram of the three-tier architecture are using the same domain name via DNS service, right?
Yeah, right. So that's exact. I mean, the idea too is that you could set up DNS round robin, where you could have one DNS resolved to multiple IPs, and that will allow you to have a first layer of load balancing, and then the second layer being the load balancers themselves.
Yeah. Good. So let's move well, if you're going to try to optimize your application, you need to understand it, and in order to do that, well, you need a lot of information and metrics and a very efficient way of displaying them and looking at them. So I think most of you, if you are using RightScale, must be familiar with some view like this one, because we provide every server template, and as you may know, the server template is the set of instructions that we package as a unit, and that represents the configuration of a specific server. Maybe it's a load balancer, maybe it's an application server, maybe it's a database, that when you start an instance on the cloud, you load the set of instructions, and then the server configures itself. Now, all our server templates that we provide to you, like solutions, they already have a pre-configured installations for collective monitoring, so that we collect all the software and hardware statistics, and we send it to our servers, and then through our dashboard, you can look at them. So here's an example. It's just an arbitrary example of what you may see on a server. And in this particular case, what we have is some number of dimensions of metrics that you can take from your hardware in this instance. In this particular case, for example, metrics that have to do with your CPUs. And if you have two, you will have basically a set of for each of them. Then if you want to know something about your disk file system, you also have some information about maybe how much space are you using. Then, depending on how many disks you have attached to your instance, you may have statistics for each of them. The network interface also, we provide statistics about packets in and out, maybe the volume, and also the number of errors. The load of the system is important, the memory consumption, and then in this particular case, it's a Rails server, so we have some information about the Rails processes themselves, and also about swapping and so on. So for each of these, let's say, macro dimensions, there are a set of metrics that tell you something about what's happening on the server. For the CPU, it's an overview of the CPU, that is that how the time is being consumed, either idle or by user time. And you may also see the system time and the wait time. In addition, if you want to go deeper and find out about idle time or the amount of interrupts that your application or your server is experiencing, you can also look at that. Similarly, here's an example of a graph that is showing you how much swap space has been used, so that in this particular case is very little, but it's something important to monitor. In addition, we also provide on our dashboard what we call the quick monitoring. That is that you can select some relevant graph that you may want to monitor all the time. And here are some examples of them. And you just select them, and they're very useful. Now, this information is the first level, and normally works if you're doing dev and test, or if you're running a very simple application on the cloud. However, if you really have a successful application that maybe requires hundreds of servers, tens of hundreds of servers, suddenly looking at one server at a time and one graph at a time is not convenient. So what we have done is to expand these the graphing tools and basically extend it so that we have more rich ways of displaying the information. And here I'm going to show you three examples. One is a collection of individual graphs. This is for if you have maybe 10 or 20 servers. It's interesting because you can show, for example, the CPU consumption for all your app servers in a single shot. And you may want to change the metric, you may want to change the time scale, or even the size of the graph, and you can do it for all of them at the same time. So it's very useful. Now, the limitation with that is that sometimes you want to see the aggregate performance or the aggregate contribution of all your servers. For example, are all my application servers consuming more CPU than they were doing 5 days ago? And the problem is, if 5 days ago I was running 7 application servers, but now I'm running 6, then it's not easy to do it on the individual graphs. So you may want to use what we call stack graphs, that is a way to display the contribution of many servers so that you can see the total of all of them. It's also they're good to see the sum and the variability in activity in the cluster. And some limitations is that sometimes it's difficult to make up individual servers. So it's in this particular case you want the aggregate contribution. And finally, as we say here for stack graphs, sometimes it's difficult to make whether individual server maybe is overloaded or maybe is not taking as many requests as other servers. So you need something that can highlight those differences. And that's why we create the notion of what we call a heat map. And there is that each server is displayed as a track in a graph, but we use color to indicate the intensity of the metric. If the metric is very high, we may use a red color. If the metric is very low, then we use a blue color. So by just identifying patterns, it's easy for you to identify differences between your servers. And let me show you examples of this. So, okay, before that, just you may be curious how these graphs are produced. Let me give you more or less how it works on RightScale. So here is maybe hundreds of servers, or maybe thousands, tens of thousands of servers that we manage through RightScale. Each of them that is using our server templates have installed the monitoring tools so that they are continuously monitoring themselves and sending information to a farms of servers that belong to RightScale that collect all these statistics and make them available to the dashboard. These statistics, they are coalesced in some multi-server graphs so that they are computed and displayed to you. In this particular case, you can see here maybe the contribution of maybe 20 servers. So what we have is some servers that are processing these requests from the dashboard, collecting the information from our servers that are receiving information from your servers. So it's a neat architecture. So, okay, what is the cluster monitoring? So the idea here is that instead of looking at one graph, you look at the cluster of graphs. For example, if you have 8 application servers, you want to display all of them so that you can see how each of them is doing. And the nice thing, as Rafael mentioned, is we allow you the use of tags, so you can select which servers to display based on the tags. If you are smart about tagging your servers and identifying them, for example, this is the front-end UIs, then it's easy to select maybe your front ends versus your databases, maybe your load balancers, maybe your main caches. And by doing that, suddenly you change your graph. You may select a metric that you want to see, and then here what you have is a single control panel that allows you to change the size of the graph and the time metric. So it's very convenient, and we use it a lot ourselves. Now, the problem with this is that how do you know what is the contribution of all of them? Or if you have 30 servers, then it's difficult to try to measure things here. So for that reason, we go to another type of graph, and that's a stack graph. And I'm showing you exactly the same information as before, but in this particular case, it's requests per second, and it's the contribution from all the servers. It's over a period of 1 week, and as you see, is what you will expect is that during the week, during peak hours, probably between 9 a.m. to Eastern time and maybe 5 p.m. Pacific time, your application is heavily loaded. It has a lot of requests, and then during the night, there are the load goes down, and maybe there is a peak. Maybe this is Asia, maybe it's Europe, and you have this pattern that repeats itself. Saturdays and Sundays, you see that, well, people are not using our site that much, so that the load goes down. Now, the nice thing about this is that you can make comparisons of the overall contribution. If you are adding more and more servers, then what you want to know is the contribution of all of them, and for that you need to dynamically adjust. And by using tags and using these graphs, you can do it very, very efficiently. Okay, so this is great, but then how do I identify that a server is maybe overloaded or the server is not contributing as the other ones? Okay, so these graphs are not useful for that. So in order to do it, we need another type of graph, and these are what we call heat maps. The idea here is that each horizontal strip shows one server. So you can see here in the previous example, we have 8 servers. Here we also have 8 servers. Each of them has its own track. And then for this particular metric, that is the CPU overview, the percentage of busy time, we use color to represent the intensity of the metric. So if it's close to 100%, it's closer to an intense red. If it's very close to 0, then it goes to blue. So as you can see, again, over a period of 1 week, the red zones identify the peak times in which most probably your users are active. Now, just these 6 servers are functioning normally day and night, and this is what you will expect. Then this server, for some reason, it's completely idle. It may be that it's a test server, and I think that's what it is. It says here testing. And then someone decided to launch maybe an array, scale itself automatically, and then a new server was launched, or maybe we just trying to see ahead of time for the next week and reduce the load on each of the servers. A new server has been launched and is now operational. So these graphs are very, very useful, and we use them themselves every day, and I'm going to show you an example of something that we discovered recently by just using these graphs. So here what you're seeing is the heat map for 100 servers. Now, these 100 servers are contributing more than 60,000 data points. What we're doing, and I think I showed you before, is these servers are taking the definition of the graphs and then pulling the information from the farm of monitoring storage servers that we have, and then constructing a graph to show all the information. So these 60,000 data points representing a period of maybe 12 hours, and then everything is working fine, at least up to from 4 to 6, and suddenly 6 or 7 servers start to be overloaded. Now it's easy to see these patterns and to then try to see, okay, something must be wrong that is causing these servers to be overloaded while the other ones may be idle. And we need to find out the reason. So the combination of a heat map here with a stack graph, that here it shows the number of active servers that the monitoring servers are servicing. It shows that suddenly around Wednesday in the morning, the number of servers that were launched increased significantly. And that is the reason why the allocation algorithm that decides which servers have to send information to a specific monitoring server, suddenly many of our servers receive too many hosts in a short period of time. What we discovered by just looking at the code is that there was an anomaly on our allocation server that somehow was not responding fast enough to the assignment that were made in the last maybe 10 seconds. So it was keeping an old load statistic and concluding that the servers were not highly loaded. So that's a usual problem with the control systems feedback, in which you really have to respond fast enough in order not to do these kind of mistakes. So I think the conclusion of this section is we provide a lot of tools and a lot of information and a lot of monitoring data that allows you to track the performance of your application, detect anomalies, and continue optimizing it. I think we're going to change now to a different, a more analytical analysis of the performance of your application using New Relic. And Raphael, the French accent, is going to talk about that. But let's see, we have some questions.
Okay, so the first question is, can the load balancer vote to grow the array? And the answer to that question is it's possible. You could run the load balancer in the same deployment as the server array, and then it will be able to vote, tag itself as saying, hey, we need to increase the number of instances in this array. But that's probably not how you would want to do it usually. Usually the app servers are better suited to know, what the load is. And the idea is that each app server is going to vote individually to vote. Maybe you just got a flood of requests, and let's say that 4 of your 10 app servers are overloaded, so the 4 of them will vote. But because you set a threshold in the server array to say that at least 50% of the application servers in the server array must vote before the array is grown, then this will not actually impact the size of your array. We would not launch a new server, even though 4 application servers are being overloaded. So you could maybe there's a use case out there where you would want a load balancer to vote, but that's not usually how you would do it. You would usually put the tags on the app servers themselves.
Yeah, one reason I will say that normally people don't use the load balancer is because the view from the load balancer in a way is indirect. is that you may be doing health checks or maybe running using requests per second to make conclusions about whether you have to add more app servers. But I think the most direct measurement is the app servers themselves that are telling you that they are overloaded. But as Rafael said, if you want to do it that way, there is no limitation in that respect. The second question is, does the monitoring system offer anything in addition to what open source monitoring apps, e.g. Ganglia, offer? What benefits does this monitoring offer? So I think I should start by saying that what we use as monitoring, or at least the collection of the statistics, is open source, is CollectD. So it's something that is very popular and is used everywhere. Maybe what is not open source in a way is what we have built on top, that is the displaying, processing, and the integration of the monitoring data into our dashboard. I will not say that the monitoring tool itself is really very different from what others are there in the market. I think this is what we have built on top of that, and the integration into our dashboard, and the fact that is multi-cloud, that is that the same tools and the same graphs and the same information is displayed. It doesn't matter whether you're running on EC2, or you may be running on Rackspace, or you may be running on maybe in a private cloud, maybe Eucalyptus or cloud.com. All the servers, by using a server template that is the same and using a multi-cloud image, you can launch them and see the same information. You may display your graphs, maybe your stack graphs, coming from different servers running in different clouds. And I think that's the added value that we provide in that respect. And I think that's what really is different.
All right, thank you. So we're going to move on to Nordic. So this is an example of a partner that specializes into performance analytics, and so I'm going to show you how you can leverage that through RightScale. So an overview of Nordic RPM. This product is specializes into analyzing the performance of applications that can be written in Ruby, PHP, Java, or .NET. They will also show you performance analytics about databases, including SQL and NoSQL databases. They track web transaction, and they will actually trace every method that is involved in a web transaction if you want to monitor it that way. You can also, kind of similar to what you can do in RightScale, you can also specify thresholds that if they are reached, then an email needs to get sent to somebody or some other trigger somewhere. And finally, it's scalable, meaning that it will, for you, it's very transparent whether your application has two hosts or whether it has 100. The way you use the tool would be very similar. So what we've done with them is we actually integrated their dashboard inside the RightScale dashboard. So if you go in the report section of the RightScale dashboard and you click on the Nordic RPM tab, the first thing you'll see for the first time you do it is a prompt that's asking you whether you want to create a free account with them. And if you do that, we will create the account for you automatically. And then what you have to do is configure your application servers to install Nordic at boot time. And we have a REST script in library that does that for you automatically. So you just add this REST script to your server template, and any application server to launch running the script will then appear in this dashboard. Now this dashboard is just meant as an overview. Whenever you click on any of the links in there, you will get actually redirected to the Nordic page, which has much more information and where you can drill down to what happens if you see something strange at the dashboard level. So what Nordic has in particular is it gives you a historical statistics, so you can decide whether you want to see the statistics for the last 30 minutes, the last 60 minutes, and it goes up to days and even month, if I remember correctly. Also, you can drill down and look at the requests that are consuming the most time, and you can actually order that in different ways. You can choose the ones that have the most time overall, or the one that takes the most time individually, not compounded. and that way you can analyze and see what the bottlenecks are in the application and know what needs to be improved. Nordic also has just introduced this new feature called real user monitoring, where you can actually see what a user experience when it accesses your application. So it does that globally, so you can see by country how long it takes for someone in that country to access your application. And the way it does that is it basically injects a small snippet of JavaScript in the page that your application renders that calls back their server and tells their server, hey, it took that long for this page to display and that long for the data to arrive from the server. It also does a breakdown by browser, which could be interesting to see if you have something quirky with a given browser. So I'm going to give you here two real-life example of how you could use that tool to detect issues with your application. And the first one, which is very typical, is you see one request is really standing out in this list of requests, and you want to understand why it's taking so long for a request to run. And so what you can do is you can switch to this view here that will show you the slow request details. And so what you can see here is a breakdown of what happened when a request was executed. And one thing you can see is most of the time is spent into this one request, and so you'd like to drill down and see exactly what happens. And so you can go into the trace detail here and look at exactly what method during that request took all the time. And you can also look at the SQL statements, and that's interesting. And so you can see here that this request took 30 seconds to run, which is obviously not acceptable. So you need to look into it and see maybe there's a missing index in your MySQL table or something like that. So you can click on this button here and actually get see where in the code that query gets run, which is very useful. I mean, if you have any experience with Rails, for example, you will know that sometimes it's tricky to correlate SQL queries with the code, and this tool does it just straight up here, which is very, very nice. So you can exactly see, okay, this method from this file actually caused this query, and you can then identify what needs to be optimized. Okay, the other example I wanted to show you is what is called the N+1 query problem, which is the issue here is if you use any kind of database object relationship layer, sometimes you will a developer will write code not realizing that this simple line is going to trigger hundreds of requests. So you do account dot servers, and then now you're going to have to retrieve all the servers from the account, and it may not look bad from a code point of view, but what's happening behind the scene could be pretty bad. So in this case, what you will see is here you can see that we're running 200 of those requests of those queries just to render this one request, and same as before, you can actually drill down and see exactly what happens. And so what you see here is you see many times the same thing happening over and over again. And actually, if you drill down at the SQL statement level, what you see is the same statement gets executed again and again and again. And so when you see that, it's typically that, okay, some code somewhere is loading too much and needs to be changed to be optimized. And this tool makes it very easy to identify those kind of issues, and actually also makes it easy to correlate database activity with code, which is very nice. So going back to the presentation here, I'm going to let Raphael take over and talk about optimizing database performance. There was one question: any API support for Thrift by any chance? Or we have to build our own using that for Cassandra.
So we ourselves use Cassandra,
right,
and we have done significant work there. Now, we haven't published templates to support that, and I'm not so sure, although we have had to extend and use Thrift. I don't think that we directly at this point are offering anything support on the dashboard. What I know is that we're going to offer some server templates for these non-SQL databases for sure. Okay, so let me move to the next section, and this one is optimizing database performance. For many of you, this may seem straightforward, but I think it's always good to do that and remind and refresh. So normally what we do, at least here in RightScale, is we use our RightScale MySQL server templates. And the nice thing about these server templates is that independently of the size of the instance that you use, we have already configured them so that they are the configuration files are optimized to the instance size. We have tailored the different parameters that are critical to the performance of database, so that if you go from a small or to a quadruple extra large, you will expect a good performance. Now, as you all know, if you are in operations and you have to worry about the performance of your database, it's a never-ending task of identifying bottlenecks. That's basically something that happens continuously, especially an application that changes rapidly. Maybe if you have updates once a week or maybe once a month, so you discover that new functionality that your users may love and suddenly may put a lot of stress on your database. So you have to be monitoring all the time your disk 6 and the performance of these operations. You want to minimize them. It's very important that you have the instance size that you use is such that your working set fits in memory. The moment that your working set is larger than your memory, what's going to happen is that you will have to start doing some going to the disk to load the information, and then you may go to and to start doing swapping. Databases are very sensitive to this. Once you are not running out of memory, your performance degrades very rapidly. So what is important is to constantly monitor the performance graphs, your logs, and also to understand your queries. You have to know your schema considerations, how basically changes in your schema affect performance. So how do we do monitoring of database performance in RightScale? So again, we use the standard collect D statistics, and we focus a lot between user and wait time, so that we know that these operations is as it's a minimal part of the normal operating of the database. We also tend to scale up when working set cannot fit in memory. If you are using a SQL, maybe a MySQL, or maybe an Oracle, the traditional transactional database, that's the only possibility that you have. Otherwise, you would have to start doing sharding. And sharding, it's a great solution to scale, but well, it's normally requires a lot of architecting in order to do that. If you are going to a non-SQL databases, then the problem of scaling, that you don't have it. You have other set of problems there, but that seems to be for a lot of applications, social apps. They tend to be a perfect kind of database to use. So let me just focus in MySQL, given that most of you said that you were using it. So we provide our templates, MySQL Collect D plugin, that monitors like 40 to 50 different metrics and gives you a lot of information about what's happening in your database. In addition, something that we do here at RightScale is that we constantly monitor and mine our MySQL slow queries file, so that we identify slow queries as soon as they happened, and we continuously try to remove them. For that, we also use the MySQL explain command to identify the query plan and see whether there may be some indices are missing and so on. So what is that the Collect D plugin in MySQL captures? Well, it captures most of the statistics that you will find by just using MySQL, and it collects that information and sends it to our servers. Number of connections, the number of I/O requests, the rates of selects, reads, also how your keys tables are basically accessed, how is your query cache behaving, and the memory and so on. Let me show you an example here. This is taken from one of our servers, and as you can see, here is the MySQL plugin, and is displaying something like I think is 56 graphs in this view. And there are overall graphs, for example, what kind of operations are being executed in the database, what are the performance of your reads, how many of them are table scans or scanning of your index and so on. Also, how many data are being sent in and out of your database, how different commands are being executed. So by monitoring these, you have more or less a view of the health of your database. So these may allow you to detect some anomalies, and then you have to normally go to the actual machine and start understanding what is the kind of things that are happening there and why these may be expensive. I think this is the same example that Raphael showed, that is, this is the select that was identified by New Relic as being an expensive one. And you can see here that exactly in the slow query file, it says that this query took 29 seconds. And part of the reason is you have to examine 132,000 rows. So by using the explain command on the specific query, we can understand that, well, that even when we have a compound index between the account ID and the cloud ID, somehow the number of elements in that set that matches this combination of values still is 100 or maybe something of 161,000 records. So that's part of the reason why having to scan for all these records, even when we're only going to return 1,700, it's basically taking a lot of time. So I think it's something that by knowing this information and then going back to your application and modifying your queries, or maybe by adding an index, you can improve performance. Here is a graph of an arbitrary database. And as you can see, it's a database that has some room to grow, and that most of the time is spent in user time, and that's good news. It means that we're doing useful work, and that the wait time that is shown here as a red amount, it's minimal. And therefore, you want to keep the performance in that way. Suddenly, when you start seeing that the red zone increases, then probably you have a problem. Either you are loading information from the disk, and probably your working set does not fit in memory, and that's something that's a no-no. Then another type of graph that is important is to see whether your select, what kind of reads they trigger. And what you want is that you don't want to do full table scans, basically to look at all your records, so a very large set of records in order to find information. What you want is to use the indices, so that whenever this blue line goes too high, maybe out of the normal level, or that it dominates relative to your read index, then probably you have a problem, and it's time for you to start tracking in the logs to see what is happening there. I think that's all that I want to say about MySQL. I think we're going to finish a little bit with how to do load testing, and Raphael PH is going to tell you a little bit about that.
Okay, and before I go there, there was one question regarding Nordic, which was whether it supports non-open source applications and databases, and I think the answer is yes. Nordic works at the ORM level, so it actually doesn't care what database is used beneath. What it will do is intercept the calls made to the database by the ORM layer, and that's what it's going to send for the metrics. So they support .NET, PHP, and Java, meaning that they will support SQL Server and probably Oracle. I cannot say for sure, but if they support Java, they must probably be supporting Oracle as well. Okay. So this last section here is about load testing, and so we've covered how you can optimize your applications in the cloud using vertical scaling, horizontal scaling, or actually improving the performance of your application, and also tracking issues at the database level. Now the next thing you want to do is also keep testing and keep making sure that none of the new feature that you add to the product is going to have a big impact on performance. And the way you do that is you have a standard set of load tests that you run against the product. And so what we do to help in that regard is we have produced a HTTP perf server template that you can find on the marketplace, in the RightScale marketplace. And you can very easily launch as many of them as you need to produce the kind of flow that you need on your application. We also have a nice tutorial explaining in details. So that's the server template here in the marketplace. And you can see that we support Amazon, we support Rackspace, we support Cloud.com and Eucalyptus server templates. So you should be able to use that no matter what your cloud is. And also we have the support page here called Adding HTTP Per Flow Tester, which describes how to use a server template, how you can configure it for your specific needs. And I think that's about it. That's wrapping up the webinar here.
Okay. Thanks, Rafael. So I think let's have maybe some Q&A. There are some questions here. The first one is it possible to automatically launch an application by using the monitoring tools that you have?
Right. So this application. Oh yeah. So what?
I think let me answer that one. I think the answer is yes. By using an escalation, what you can define an escalation that says if a certain metric reaches a certain value, or maybe your application is not responding, your server is not responding, you can trigger an escalation, and an escalation can do a relaunch of a server, or it can reboot the server itself, or it can run maybe a script. Maybe the reason is that one of the processes die in the machine, and what you want is just to restart that process. So yes, I think we have different ways of responding to an escalation. One can be to send an email. You can send email to a number of people, and also you can have different levels of escalation, so that, for example, you may send an email to your operation guys in the first minute that the escalation happens. If the escalation continues after 5 minutes, maybe you want to escalate to the manager, and if the escalation continues, then maybe you want to send to other people. In addition, your response, whether to restart the process, can be your first response, and maybe if that doesn't clear the alert, you may want to basically reboot the server, or maybe launch a new one. So I think that we have a variety of ways of responding to when something bad happens to our application. I think we're running out of time, so probably we wanna stop here.
Mm-hmm. Cool, and I'll just jump in right now. Thanks everyone for attending. We're going to keep the webinar open for a few more minutes, so if you have any questions for the team, feel free to continue asking away, and we'll get you answered right away. I want to point out that today's webinar was recorded, and after we close this down, it just needs to compress. We'll upload it to our site later today, and we'll shoot you an email tomorrow morning to let you know that it's ready to view. You can check out this webinar or other archives at our website, rightscale.com/webinars. We have a slew of other resources available for you as well, such as white papers and videos that deal directly with the topics that we discussed today. Make sure to check those out. Stay tuned for our webinar next week with Daryl Eaton, Automating Servers in the Cloud. This will be a deep dive into RightScale's powerful server templates and how you can customize and create your own. And also, if you'll be in the Bay Area in the beginning of November, we're having our RightScale conference. The 8th is a training day, and the 9th is our full conference day full of content from our RightScale experts and our partners. So make sure to join us for that. You can register at rightscale.com/conference. Otherwise, thanks again for attending, and have a great day. Bye.